Welcome back to Algebra 2. We're looking at 6-6 function operations, and we will be looking at the sunshine state standards of performing operations of functions algebraically, numerically, and graphically. We'll also be determining the composition of functions. So what is our objectives for today? Well, we're going to be looking at adding, subtracting, multiplying, and dividing functions. And we're also going to find the composition of two functions. So let's get started. Let's get our brains jostled with some real-world-like problems. You want to buy a sofa that has already been marked down $100. Now, the furniture store may add the 5% sales tax before applying the discount, or it might add the sales tax after applying the discount. Which way is going to be better for you, the customer, and how much better? Well, today we're going to be looking at functions, and the final cost of the sofa involves two functions, one that gives an additional discount and one that multiplies to find the sales tax. In this example problem, we're looking at changing the order of these functions, one of the big concepts for today. So what's our focus question for today? How are function operations different from operations on real numbers? Just like we talked about a discount, a markdown, that's a subtraction, and a sales tax, that's a multiplication. We're dealing with different operations on functions. You can add, subtract, multiply, or divide functions based on how you perform these operations for real numbers. However, in this case, with functions, you must consider the domain of each function. So let's take note. Here is some notation we use for functions. When we add functions, we could say f plus g, or we could say f of x plus g of x. When we subtract, we could have f minus g, or we could have f of x minus g of x. When we multiply, we could write f dot g, where that dot means multiplication, or we have f of x times g of x. And division has f divided by g, or each function divided by each other. Now notice here in division that we have g of x not equal to 0. Remember that the denominator of the division cannot be equal to 0. And that's going to be a restriction on the domain. So if you've forgotten, domain is all the x values or the inputs into a function. And the domains of the sum, difference, product, and quotient functions listed here consist of the x values that are in the domains of both f and g. So what that means is if a number works for the f function and it works for the g function, it will work for both. But if a number works for the f function but does not work for the g function, at the very end we cannot include it in our domain. Let's go ahead and look at how it works for the quotient function, another way of saying division. It does not contain any x value for which the denominator is equal to 0. So let's take a look at problem 1, where we're going to add and subtract functions. Adding and subtracting is very similar, so as we look through it, we want you to look at the similarities and the differences between them. So if f of x is 4x plus 7 and g of x is the square root of x plus x, what are f plus g and f minus g and their domains? So there's going to be three parts to this problem. Let's go ahead and look at the first part. F plus g parentheses x. Well, first, knowing the definition, that means we're going to add the f function and the g function together. F of x plus 7 and square root of x plus x have like terms. So f of x, 4x, and x, we can add those two together and we get 5x. Square root of x comes next and 7 comes last. This is because we're putting them down in descending order. Remember, exponent of x is 1. And the exponent of square root of x is 1/2. Now on the other hand, for subtraction, we need to take special care that when we subtract, we're going to distribute that minus sign before we subtract. This is different than what we talked about the other day. Notice there's no exponent here, so yes, you can distribute. And then we'll have 4x plus 7 minus square root of x minus x. So that's why the 4x minus x will give you 3x. and this is a negative square root of x, and then a 7. So let's talk about domain. Remember, the domain has to work for both the f function and the g function. Looking at the f function, there's no restrictions. X can be any number. But if you look at the g function, square root of x can only be numbers that are 0 or greater. So we write that the domain of g is all real numbers x greater than or equal to 0. If you put those together, that the domain of f is all real numbers and the domain of g has a restriction, then both the adding function and the subtracting function results in the set of numbers common to the domains of both f and g, which is all numbers greater than or equal to 0. All right, if you got it, go ahead and try out this problem. Find the sum, the difference, and the domains.